snug that up there. Before we can chuck this up in the lathe there, we need to create some kind of soft jaw or pad spacer to grab a hold of this diameter with the chuck without putting chuck jaw marks into that. We have some scrap here, some aluminum from the shear, and we're going to just take it by hand. Whoop. And we're going to shape it on around. Okay, we have a nice round there, and we'll take the hacksaw and we'll cut it there and there. And then we can slip this into the jaws, and then this can go in and we can grab a hold of this without harming it. Okay, we're spinning this shaft assembly in the lathe now, and this is reading the circumference close to that gear, and this is riding on a shaft out here where we intend to kind of hold on to it. Now I notice with those 2 points basically just about running true, we're looking at the end, and you can see the gear rocking back and forth and the end of the shaft. So there's a bend on that shaft underneath that gear. So I'm going to press that gear off and take a close look at the shaft there. See what we're going to have to do to straighten that out. This is the little shaft out of the 1830 clock downtown Dennis and the church there on Route 28. I've got it set up in a V-block here with a piece of oil paper underneath here, and I squirted some lube in there so we can get the nice true V-block running here. And we've checked it here and here, and we're running right on the money within tolerances there. Alright, we were going to stub the end of this shaft right here. We were going to stub it right there, but we put it in the big lathe, got it all set up, and nothing here runs true, so we brought it out here to prove what we need to do. And we checking the run out on just that side of the gear, and we got 15 thousandths run out right there. And then we slide it on down here about the end, and we're a little bit, maybe 20, 21. I'm not on the zero there, but you can see. So we basically got a crankshaft going on here. There's a little bit of a bend, but it's mostly a crankshaft. So now we think it was stubbed back at the end of this gear here at one time or another. This thing is pretty old, and it might not have been done as true. So we're going to go ahead and cut the shaft back here, and we got to take care of seeing if it was attached there at that gear. Maybe even get that gear off, but we'll stub it from that position there. So here goes everything. Taking a hacksaw right to this piece. $18.30, we're cutting it off. Okay, we're getting ready to set the clock gear in here, and my standard 4-jaw for this lathe, it doesn't close small enough to grab this end of the gear. This is not uncommon, but it's not a general practice, except for I have a nice chuck that fits safely within my 3-jaw and gives me the 4-jaw atmosphere here. Now the aluminum piece that we bent around to protect the jaws from digging into this surface, I've put in there. And then this is the only lathe with a steady rest, and that's why I'm using this lathe. Okay, because I need to support this and hold it right here rigid enough and do my machine work on the end of this gear. So let's get it in. With that aluminum shim that we put in there on the jaws, it protects, but it also acts like a pivot bearing, so that we can hold the thing in a straight hold off the end of it. and a combination between tightening and chuck to claim running through here, and then a plastic mallet so you don't damage the teeth, lightly tapping the alignment here. We're able to get that shaft running at both of those points within 1/1000. Now this thing's going to be coming in, out, several times. But this purpose of it being in right now is we're going to get some of this machined off of here. We're going to expose where the shaft is actually protruding through that gear, and then we can make our plans on pulling that off of there, and then we'll go from there. So right now we are set up, and now we're going to bring in our rollers on a steady rest, but we got to pull the indicators off so we can do that. And we're going to do it without moving the shaft. We need to maintain it. So we're going to creep up, holding our rollers with our fingers so that we're just barely holding it true. And then we can get in here. Once we put a center hole in there, then we can hold it hard. Center drill, we have a precision location for dialing it back in or setting up and running a board. We pressed the gear off, and that was the side that was near where we faced. It appeared to be a keyway, but all it is basically a broached notch to act like a keyway, and this is very popular in a lot of old tools because you can set up a boring bar and screw your compound on your lathe, and you can create cutaways in bores for locating and stuff like that. The shaft has got a pin in here at the same diameter of the groove, and that's acting as a key, and this is very common pin and notch for keyways in the olden days. But now what we got to do is we got to go ahead and stub from this point on. Now we're going to bore in there and make a stub that's going to come out here and give us this diameter here. We'll have to redo the taper pin holding the next piece on there. This is a diameter for a washer, and the lock ring. Here's the threads for the locker. There's another bearing diameter. So we got to time all those in. But we can do this now, and we can make that 100% running true with the axis. And then we'll have this thing running just like it was in 1830. Okay, one thing that I did notice, and this is what I really wanted to know before I do any welding or attaching any stub shaft in here, by drilling it, you can see how flaky, easy, and how shiny the chips came out. That's telling me that this is somewhat of a leaded stock, okay? And that leaded stock means that you're not going to be able to weld on it, because welds are not going to take well with leaded stock. So I'm drilling and tapping, and then I'll prepare a tapped in on the male stub that I'm going to stick in there, and then we're going to silver solder it. Now, this is going to be the drill size here, but there again, here's another example of watching the chip, and you can see how pretty they peel out. You get nice uniform cold roll. Other steel, they won't be so glossy. Pretty much like butter. It's almost like drilling into aluminum. Alright, little starter tap here. Tap fluid. using the live center to follow the tap gives you a nice true hole tapping in the lathe. Alright, this is a 7/16 thread we're putting on. This is going to be the male thread that's going to screw into the stubbed opening on the clock shaft. We took the file, we drew file radius this because we're real close to the bottom, and those threads are bottoming tap, but they still don't go sharp all the way to the bottom. And this now screws on and goes right to the shoulder. This is the fit I'm looking for. Now we're going to go ahead and we're going to coat our threads, and don't be shy with this. You want plenty in there. Now, even though we got that amount on this thing here, you want to apply it in there. Okay, now ideally a little screwdriver or something, but if you don't have something like that, you can make a little paddle with a piece of aluminum TIG rod. A couple little hats like that, and you got a little paddle. Okay, now you can reach in here and you can scoop up some, and you can force it into all those threads in there. And here's another piece of scrap, making a good tool. That looks a little skippy right there, but it's going to be fine. That's all filling in right there. Alright, we're going to let it cool down right down to room temperature before we go put it back in the lathe. We got it set up again in the lathe there. We're going to start turning the diameter. Okay, the diameters are all roughed out, so we'll be just doing a little polish, a little face on the shoulders. That one this will get threaded here. This is finished diameter here, and it's time to go ahead and start doing our stack up. And we're going to put the gear on here, and it goes on about right to there, and we're going to press it on with a piece of aluminum here. We got face stop at both ends, and get that centered up there. And we're just pushing it on with the tailstock. Okay, I felt it roll and line up with that pin.
And if your car was damaged, cover broken windows or openings as soon as it's safe to do so,
okay,
to help prevent damage inside the car. Then call 1-800-54-STORM.
Alright, that gear is on for good again, and it doesn't need to be peened or mushroomed over, and that shoulder doesn't need to be fit. That's why it was sticking out about 10 thousandths before. I'm a little bit more, but that's hitting there. I'm going to just make sure that we're not catching shallow. And that gets the taper pin through there. Now that face has got to be trimmed down true with that face, because everything else thrusts against this face right here for the clutch.